Welcome to ChemIllusion. My name is Joshua, and I'll be taking you through a demo of our NMR tool. To get there, we'll go to the canvas, which we'll go to Create, and here we are on our canvas. To access the NMR tool, we'll go to our 3D projections and teaching diagrams, and then select the NMR icon on the far right. Here we have our NMR tool, which has signals and typicity, splitting trees, spin state diagrams, and a spectrum simulator. With our signals and typicity, we can look at our molecule with highlighted environments. We can add the image to the canvas or add an editable fragment to the canvas. We can also see that we have a proton NMR and a carbon-13 NMR selection options. We can see the proton NMR environments A, B, and C. And with the carbon, we can see environments A and B. We can add environmental labels to our canvas by highlighting all of our environments and adding labels and a count callout. They'll appear on the right side of the canvas where we can click and drag them into a position that we want. Going back to open our tool, we can clear these annotations by selecting this button here. We can compare a site on the molecule that we're using. Here we're using ethanol, so we can do our first carbon, compare it to, say, our oxygen. Once we compare the two nuclei, we get a result that says this is a constitutionally heterotopic molecule that has different signals at these positions because they are constitutionally in different parts of the molecule. We can show an isotope test, which would appear here after some rendering, where we can see a replacement structure A or B, and these two structures are constitutional isomers of ethanol. Down at the bottom, we have some assumptions and warnings. Going over to splitting trees, we can look at the splitting trees for our proton NMR, where we can select the signal we want to see. So there's signal A with a triplet with a 1-to-1 split, signal B, which is a quartet, which would be a 1-3-3-1 split, as well as signal C, where we have simply one signal. We can also adjust the J values or the frequency, as well as how many splits if we just want to modify it ourselves to see what a splitting tree would look like. And we can add the tree to the canvas and add a multiplet callout. The multiplet callout will be on the right side of the canvas, and we can position this however we like. On spin state diagrams, we can see a spin state diagram for what would be two neighbors, which would create a triplet combination with a 1-to-1, along with the spin states above the bar graph. We can do that for one neighbor, three neighbors, and also four neighbors. Now, if we're looking at a molecule on this tool, we can select signal A for environment A split by 2 because signal B has 2 protons. So we'll see that signal A will have 3 spin states, which would create a triplet, so a 1-to-1. And we can also do the same with signal B. Once we're happy with what we see, we can add the diagram to the canvas and manipulate it as we need to. Lastly, we have our spectrum simulator. So here we can select between our proton environments or carbon-13 environments. So we can have simulated chemical shifts. So these shifts are simulators. They're only for teaching illustrations only and not predictions. But we can look at these within different frequencies from 60 megahertz to 600 megahertz. We can see a carbon-13 NMR on a scale of 0 to 60, which the full scale would be around 220. And the proton NMR, where we see from like 0 to 4 in this example, with larger molecules having a broader spectrum. So we can adjust the frequency to see how detailed the graph is, but we can also adjust the solvent region. So for reference, we have a CDCl3 reference, which gives us a residual CDCl3 spike at 7.26. which is about where you would expect it to be in a real situation, a real NMR. We also have DMSO, D2O, and CD3OD references. Beta and Charlie environments. So we have a triplet, a quartet, and a broad singlet. And with this, we can adjust the numbers using these buttons here, or we can type in a number and adjust where the spectrum lays on the graph. And once we're happy with the spectrum that we have, we can add it to our canvas and display it next to our molecule and use it. View it here is also our fragment editor, so we can get more information on the molecule that we have selected. And that is how you use the NMR tool in ChemIllusion.